So today we're going to look at chapter 4, in which we're actually going to look at ecology. And we're going to pay particular attention to community ecology, population ecology, and how that applies to the human population. When we talk about ecology, we're really talking about how an organism interacts or how organisms interact with each other and the environment. And more specifically, we want to know, well, how these interactions provide the natural capital that living things need to sustain themselves. I mean, how does organisms interact with each other and the environment, and how do they provide both these biotic and abiotic sources that they need to sustain themselves? And again, we're going to focus on community and population ecology and how this affects human population. So these are important sources that we're going to have to know to maintain sustainability. A couple of things first, just for some quick definitions. Let's take a look at what we call an ecological niche. And an ecological niche is basically a job an organism has in its environment. Um, how an organism fits in its habitat, food chain, etc. We can kind of break it down into generalist species. These ones have a broad range of habitat, food sources. You're talking maybe omnivores. Um, so they can eat plants and animals. They're not limited with the type of source they are. And we say they have a wide range of tolerance. So they can live under a multitude of climate changes, food changes, etc. Specialists, on the other hand, have a very narrow niche, a very narrow range of tolerance. Like, for instance, the panda. So you have the panda bears, they only eat bamboo. Something happens to bamboo, and then they'll have a rough time to survive. So let's take a look at how species play some roles, or four major roles within our ecosystems. First of all, let's take a look at some quick definitions. There's native species and non-native species, and these are exactly what their name implies. Native species are species that are normally found within their ecosystem. Non-native, either they migrated into that ecosystem, they're not normally found there, or they can be either accidentally or intentionally introduced. Like, for instance, I used to teach in Kenya, and there's something called Lake Victoria. And what somebody did, I guess it was from Europe, they introduced the water hyacinth. They did it intentionally. That's a plant, hyacinth. And the problem with that plant, since it was a non-native species, it has kind of suffocated Lake Victoria. It will grow all over Lake Victoria. So no matter how many times they try to kill it, it would keep growing. So that was a non-native species. And some of these can have detrimental effects. I think nowadays they finally figured a way to how to kill all the water hyacinths. So you couldn't even use a boat in that gigantic lake. Something like in Louisiana, and somebody introduced a nutria. I think that's a rodent from South America, and that's really kind of affected the ecosystem in terms of predator and prey and stuff like that. Again, that was an intentional introduction of a non-native species. Also, a couple of things. There's indicator species and keystone species. Let's take a look at that. Indicator species, these are like smoke alarms, biological or ecological smoke alarms. If something goes wrong with those species early on, they can have an indication there's something going bad or wrong with that ecosystem. Stuff like butterflies, birds, butterflies, and some amphibians. Like if there's something wrong with the rivers or streams, these amphibians may have some problems. You can monitor that and say, okay, there's something going on that maybe we should try to take care of, etc. So again, they're kind of like smoke alarms. They provide early warning to damage to the community. And then these species are widespread. Again, birds, butterflies, amphibians, etc. These indicator species can be both native or non-native. So they can fit in either one of those categories. Another one is a keystone species. So keystone, that's something like, it's like the main part. And so what I mean by this is that maybe if some of these top predators are having problems, there'll be a ripple effect. And so if you lose a keystone species, it can damage the whole community. The whole community can collapse. Like for instance, now say that the top predators are dying or they're not surviving, and then the prey can be overabundance, and that can really throw off an ecosystem. Pollinators, like bees are good pollinators. They had this colony collapse syndrome we may have heard of. They weren't pollinating enough plants like fruits and vegetables, and that can have detrimental effects in ecosystems. Again, like something like bees in there. And so keystone species can be both native or non-native, but the main thing is if they lose a keystone species, the whole population can collapse. So let's take a look at how species interact with each other. And they can interact in 5 major ways. And a couple of these things are a little bit surprising. Um, Interspecific competition. This is where more than one species competes for the same resource. One thing that's surprising is that it's harmful to both. Most times we think of competition as good, but in an ecosystem, it's not. So say that 2 predators are competed for the same type of prey. Well, what's going to happen is even if one wins out over the other, well, they've kind of reduced the amount of resources they have. So even by sharing a resource, you've reduced it. It's less for both. Like for instance, birds. Birds, like they make these calls, their noises, and a lot of times they're doing that to kind of indicate I want this nest and this tree, etc. Well, if you have the same type of birds or different type of birds competing for the same trees now, well, maybe one bird will be squeezed out, or maybe these trees will have to be shared, etc. So competition results in less resources for both. I think that's the main thing. We normally think of competition as good, not in an ecosystem. In fact, they don't tolerate it very well. Ecosystems don't tolerate competition very well. What happens is it'll change it. So over time now, these species will change that ecosystem in order to lower that competition. So competition is not tolerated in an ecosystem. The other ones, predation, we kind of know this, predator and prey, parasitism, mutualism, uh, commensalism, it's a little bit unusual, helpful to one and neutral to the other. So again, the main thing is that competition takes resources away from one another, and that's never tolerated in an ecosystem. Again, let's go back to competition again. They can compete for food, water. Plants can compete for sunlight. And so maybe one plant can cover another one, that plant dies. They can compete for space. And again, competition is not tolerated. These organisms will find a way to lessen that competition. For instance, now, say that you have these different types of birds. The way they can lessen that competition for a particular tree is that maybe they'll target a different part of the tree. Maybe this one will target the top of the tree, the middle. And again, notice the top and the sides. This one will just be the top. So they'll try to target different areas of the tree, some at the bottom of the tree. So basically, they've changed their niche. So changing a niche is a way to lessen competition. Let's take a look at predation. And this is a predator-prey relationship. We've heard of them. And what happens is normally in these type of relationships, the predators play an important role in keeping these prey populations in check. Like you have some of these, maybe a lion will kill, I think they're called wildebeests and stuff like that. If they don't do that, that wildebeest population can overrun the whole ecological system there. And they live on a savanna plain, so that could happen. One thing also I forgot to mention is that when you had this competition, interspecies competition, a lot of it is a driving force for natural selection. Even predator-prey relationships, they're a driving force for natural selection, which is a cause of evolution. So again, competition, predation, These are big drivers of natural selection and big drivers of evolution. Another one, parasitism. We probably heard of this. Normally, the parasite is much smaller than the host. It doesn't normally kill the host, but it weakens it. It can weaken it. And again, you can weaken the host, and that again keeps the population in check. Mutualism benefits both. A good example, these are from the Nemo movies, is a clownfish and sea anemones. These things have stingers on it, but it's not going to affect the clownfish because the clownfish is going to eat the parasites that affect those sea anemones. I mean, I always have a time pronouncing those. That's a good example of a mutual benefit of both species. Commensalism, again, this is rather rare in nature, in which one species benefits and the other does not. A good example of these are egrets. They'll catch insects disturbed by the water buffalo. So they'll kind of follow the water buffalo around. As the water buffalo kind of disturbs the ground, these insects that come out, the egrets will eat. So again, it's kind of like an easy food for them. And so that's a good example of commensalism. The water buffalo are neutral to it. The egrets are benefit from it. Also, there's the epiphytes. These attach themselves to the trunks of large trees in tropical forests. They'll stay with the trees. They'll eat off the trees, but the trees are not affected by it. So they don't kill the trees. Something like mistletoe is different. So mistletoe, they grow on trees. This actually harms the trees. But stuff like epiphytes don't affect the tree, their host trees, basically. So again, this is an example of water buffalo and the egrets. You can tell the water buffalo is just indifferent to these egrets being around. So a few things is that remember, communities and ecosystems are always constantly changing. So this is called ecological successions. Basically two types. There's primary succession. This is when all the soil has been ruined. Like for instance, a volcanic eruption, maybe a glacier melting and exposing some rocky underlying rocks and stuff, and then a new ecosystem has to grow. When the soil is ruined, it can take hundreds of years, thousands of years for that ecosystem to grow back. Secondary succession, and you'll see this after a forest fire, is that there's animals run away and stuff, but the soil there is still fertile, and so regrowth will come. It may take a decade or two, so it doesn't ruin the soil. That's a secondary succession. It can regrow that ecosystem much faster. Primary succession, everything's ruined. And again, volcanic eruption is a good example. Lava covers everything. All that soil is gone. It may take hundreds, thousands of years to regrow. Again, I mentioned like a glacier melting exposes rocks. So also, you have a whole new ecosystem that needs to develop. And again, this was an example of a primary succession. The timeline is just much, much faster. You have to go from basically rocks up to plants. Secondary succession, the soil is still good. It's not going to take near as long to redevelop that ecosystem. Couple of things. Let's talk about populations. Is that populations, as we know, it can grow, they can shrink, or they can remain stable. And it depends on limiting factors. Really three things. There's limiting factors. These are physical or chemical environmental conditions, uh, environmental resistance. So these are anything that can limit the growth of a population. And then last one is the carrying capacity. So eventually, all types of population, even the human population, we're going to reach a carrying capacity, the maximum amount of people that can be sustained on Earth. Normally, again, we'll see this with human populations. Population grows quickly. It reaches a point where it grows quickly until it reaches its carrying capacity, because this is where some of the resources are not as available anymore, and then it levels off. So this is due to environmental resistance, uh, carrying capacity, etc. A couple other things also. A population can exceed its area's carrying capacity. So yes, too much that can make it sustained. And then what happens is the population can crash. It can come back. And this can reduce an area's carrying capacity. So it won't be as great as it was. If all the resources are used up or getting used up at an unsustainable pace, the population is going to drop, and it's never going to reach the carrying capacity that it once had. So I was talking about how a population can overshoot its carrying capacity. And notice, once it overshoots, the population will will die. Let me get this right. The population will drop considerably. So you look at this for a moose. It overshot. This is around 1935. It overshot its carrying capacity, and then the population just drops down considerably until it begins to level off. So if your resources are used up, this population can overshoot its carrying capacity. You saw it here, this big area right here, and then the population will crash and never quite reach the level it had before. Let's talk about different types of reproductive patterns. There's opportunist species. These are stuff like algae, bacteria, insects. They have a lot of offspring, but small lives. So small lifespans. And they have a lot of depth. So they have these short lifespans. They don't stay around very long. They have little or no parental care. A lot of times they're born self-sufficient. And again, algae, bacteria, and insects. Comparator species, these are going to be like us, basically humans, elephants, whales. We reproduce later in life, so the opportunists are reproduce almost immediately. Smaller number of offspring. We have much longer survival rates. Again, we're long time to maturity, protected by parents and potential groups. So mostly the larger animals have that. Something like a rhinoceros, it's like 18 months just to have a baby, and then it takes a long time to reach maturity. We talk about human population because this is very important to us. Human populations continue to grow. It grows at, we say, an exponential rate, at a very fast rate. But one thing to notice is that it's growing unevenly. And again, there's reasons for this. You can break it down to poorer countries or less developed countries, and then into developed countries like U.S., Europe, etc. This human population increase really started around the Industrial Revolution. So you're talking about the late 1800s, in which really it wasn't until like the mid 1800s that antibiotics, or not really so much antibiotics, but sanitation came into play. Though the Romans had sanitation too, and their populations were pretty high, but then we had a big drop off over time. But back in the mid 1850s, this is where you had stuff like antibiotics, you had stuff that killed bacteria, etc. Agriculture really took off during that time. And one thing to kind of notice, this is from the 1500s up to like the projection around 2050, is that the population grew at a very low rate. So for most of humankind, the population grew at a very low rate. Again, around the 1850s, all of a sudden, all these advances in healthcare, child mortality rates really dropped, people's lifespans really extended. All of a sudden, you had these very large population jump. But notice also that even now, the population rates are decreasing a little bit. Even though they're pretty high, they are beginning to decrease. And again, they're actually supposed to kind of like level off once you start getting around 9-10 billion people. One thing about it, we've mentioned before, is that The rate overall, rural population rate is about 1.2%. More developed countries, again, we're talking about US, Europe. I think Europe is actually losing population. Their yearly growth rate is only 0.1%, very low. Less developed countries, you're talking much higher, 1.5%. And again, we've talked a little bit about the reasons for that. So most of the population growth and most of the population is in less developed countries. So the more developed countries, our population rates are staying steady. But most of the population is in less developed countries. And again, they'll level off also though. So they'll reach a point just like US, Europe, in which they'll level off just like us. So let's take a look at some various tools to measure population growth. Well, first of all, and some of these are pretty obvious. So if you take a look at population change, it's the births. Immigration is how many people migrate to an area. So births plus immigration minus deaths plus emigration. Emigration means leaves an area. This is very specific to a very specific area. This won't apply to world population because world population doesn't make a difference if people are immigrating or staying in an area. A couple other factors, crude birth rate. In terms of birth rates, they don't give you the overall number. They'll give you like a ratio, and normally it's number of live births per 1,000 people per year. Crude death rate, number of deaths per 1,000 people per year. So again, we have population change, crude birth rate, crude death rate, and the reason they do it per 1,000 is just to keep it a little bit more manageable. A few things, again, we know is that fertility rate affects population growth. And there's two ways to measure it. There's total fertility rate, average number of children born to women in a population. One thing, if you look at it, it's much higher now in developed countries than it is in developing countries, so the poorer countries than it is in developed countries. And then there's replacement level fertility. This is kind of interesting. It's the average number of children that a couple must have to replace them. Now, this may seem a little bit strange at first because a couple is two, so to replace them, you need two. But what happens is stuff like death rates, so deaths per population, infant mortality, that affects it. So for a developed country, it's about 2.1. Less developed countries, it'll be a little bit slightly higher than that. So that's how many children a couple must have in order to replace them. And again, the reason it's not exactly two, it's a little bit more, it's because of death rates, infant mortality rates, etc. And in lesser developed countries in which birth deaths are higher, people have shorter lifespans, so their death rates are higher, it'd be a little bit higher than 2.1. One thing is, if you take a look at the population in the U.S. was only about 76 million in the year 1900, over 310 million today. And you can kind of measure it in terms of births per woman, total fertility rates, about three, a little bit higher than three, around it's around 1890s, 1900, kind of drop down. And this right here is the replacement level fertility. That's that black line right there. And notice if it's higher than that, so if the total fertility rate, fertility rate is greater than 2.1, this is for us, the population grows. So again, that's that 2.1, that's that straight line. If it's less than that, the population is going to decrease or remain constant. And so right now, our total fertility rate's around 2.1. And so we may have a slight increase in population, but it stays basically the same. So again, we're monitoring births per woman, the total fertility rate, and then we have this replacement level fertility, which is about 2.1. The population how many kids a couple must have to maintain the population. Another way to kind of understand if a population is going to grow or decline is to look at how many men and women they are to each other, their ratio, and also to look at these kind of age structure categories, the pre-productive ages, pre-reproductive ages, reproductive ages, and then the post-reproductive ages. And of course, the more reproductive ages you have in society in terms of a ratio, the higher that population is going to grow. In other countries, like in Germany, maybe Italy, post-reproductive ages are higher than maybe reproductive and pre-productive ages, and those populations are actually beginning to shrink a bit. So you can actually make a graph, male to female ratios, and normally for the most part, it's pretty consistent. You got countries like in China, some parts of India, in which they would abort the female babies, and now they have a much higher ratio of male to female. I think they're trying to change that because that's really going to be unsustainable. When you have this kind of a pyramid or triangle, this means that the population is going to grow. This means you have a population growth because you have basically, especially in this ratio, 15 to 44, you actually have more kids than parents. So if you have this kind of a triangle or pyramid shape, populations are growing. On the other hand now, if you have something like this in Germany, in Bulgaria, Russia, you'll see that parents outnumber their kids. Their grandparents greater than kids. So these reproductive ages are shrinking. Ones that are not reproductive ages are again larger, especially among the older groups. And those lead to a population shrinkage. So again, you can see expanded rapidly, expanded slowly. And the US is actually right at the rate that we want. Stable, so Japan, Italy, Greece, and then some declining in some of these European countries. You can look at the US. Around 1955, you always hear of the baby boomers. This is where they had a lot of babies. US population really increased. And then now, notice that these baby boomers, the ones that were born here, are kind of moving up that pyramid. And now around 2035, the US is projected to remain relatively stable in terms of population. So we still got a growth, but you notice it's more of a teardrop or bullet shape, no more that pyramid shape. A few things about this is it possible to reduce population growth? Three main ways of doing it is just the natural economic and industrial development. As more countries develop, and in more developed countries, populations just decrease. Parents have less kids. You can provide education, family planning, healthcare. That's going to reduce population growth. Elevating the status of women, what happens is that directly affects the first two. So these are ways of either trying to slow down a population growth or actually get it to shrink. So let's take a look at how countries, as they begin to develop, how their populations are affected. And again, we talked about the more developed countries, the more slowly these populations do grow. There's really 4 stages of demographic transitions. There's pre-industrial, which is where humankind was for most of the span of the earth. Low growth rate, and the reason you had a low growth rate was you had this high death rate. So it was offset. You had a high birth rate. I mean, people have 14 kids, maybe 1 or 2 would survive to adulthood. So it was offset by this high death rate. So the population remained fairly stable. And then you moved into the transitional. Transitional is where you get the greatest growth rate. In this case, you have improvements in food, health, etc. You still have a high birth rate, but a much lower death rate. And so this is where you see this tremendous exponential growth rate. In fact, most of the world, most countries are in this phase. They're in this transition. in which things are improving. I mean, I used to teach in Kenya. I've had friends that lived in Africa. Things have improved a lot just in the past 20, 25 years. So you have this tremendous growth rate because food, healthcare, services are improving a lot, lowers the death rate, but you still have this high birth rate. And then you'll move into the industrial phase. Uh, widespread modernization. So birth rate is lower, but still a little bit higher than the death rate. So that total fertility rate is still higher than that 2.1. You can think of it that way. And so you still have a slow growth rate. And then you're at the post-industrial level. Birth rate at replacement rate. U.S. is probably in this post-industrial level. Our population is staying kind of steady, maybe increasing just slightly with it. You can look at these growths. This may not be so easy to tell. Hold on, maybe try that. Okay. Again, the red line is birth rates. Blue line is death rates. So again, at pre-industrial, again, the green line is a combination of both. Is the population growth, total population. So it stays the same because birth rates and death rates are about the same. Once birth rate starts to increase over death rates, population begins to increase. And then eventually, once you get into the industrial and post-industrial stages, now population begins to either remain steady or starts to decrease a little bit. So again, this could be a little bit messy to understand this graph, but basically the birth rates are going down. The more industrialized a society becomes, death rates go down also. So you see death rates go down until eventually you have a level in which death rates and birth rates are the same again and population remains steady. Notice that even at the pre-industrial, you had the same number of death rates and birth rates, but in that case, the birth rates were higher and death rates were much higher per 1,000 persons per year. So overall, you have a large increase in population, but the population rates are either staying steady at the industrial and post-industrial area or begin to decrease. We've talked a little bit about it. Poorer countries will have more kids, especially now since they're in the transition state. Higher birth rates, lower death rates. A lot of this is unplanned pregnancies. One thing about this is something we don't want. We don't like to have high rates of infant death. That's decreased in most countries, by the way. And so that's probably the reason why populations are growing a lot in these developing countries. Education and clinical services. So UN says that this big drop in total fertility rates in countries or less developing countries is due to education. Again, factors that lower total fertility rates. Again, we're familiar with these. Education, people have kids at later ages, especially women, so they have less kids, paying jobs, and you're always thinking about, can I afford these kids? Economic factors, especially in more developed countries, you're more apt to want to give your kids a lot more stuff. And so that has a tendency to have less kids. In some of these poorer countries, they're thinking that, well, maybe one of these kids that I have will become successful and come back and help me out. So that's kind of the reason behind it. Birth control has lowered fertility rates. Elevation of women's statuses. They're getting more educated. Jobs has lower fertility rates. One thing about this is that when we talk about a sustainable society, we don't really want a population decrease. We don't want that. We want sustainable population growth. I think that's the main thing. There is problems with sustainable population growth. That doesn't mean a decrease in population. That's extreme. We want a sustainable population growth in which we have all the stuff we have now, in which the population will flourish, life will flourish. That's what I mean by sustainable population growth. There's problems with rapid population decline. Economic growth is going to stagnate, labor shortages, less taxes, so you have less government services, less people to do entrepreneurships and business formations, less technology development because you have less people. The pool becomes smaller. Um, Higher health care costs as the population gets older. Entitlements may go down. So I think that's one thing I hear. People are thinking that we want a population decrease. This is sustainable. That's not sustainable. We want a sustainable population growth in which everything flourishes. That's our goal into sustainability. We don't want extremism in which we go live in caves and stuff like that. We want to live the way we're living now, even better. It's just not, doesn't really make any sense, or these people really, there's no way for us to go back. We're not going to go back to caves. We're not going to go back to doing less. We need to sustain the services we have, the stuff that we have, but make sure that everybody gets a part of it, and then our population will flourish. For our Zoom discussion, uh, kind of think of the year 1900. In fact, my grandpa was actually born around 1898. And think about how society and quality of life has changed since then. Look at factors that have increased population growth, which ones has decreased population growth. Look at changes in food, health, social structure, etc. And come to class. So again, food, health, social structure, and we'll have these discussions. Again, thanks for listening. Again, email me if you have any questions about it.